The third way that we can control our exposure is by playing with the camera's sensitivity. Sensitivity is a little bit of a misleading term, but it's the commonly used one, so we'll stick with it. Your camera has an electronic sensor that's basically a solar cell. When light hits it, it generates electricity. You can take that signal that's coming off of the sensor, and you can use electronics to make it stronger or make it weaker. You can process it to make it as if the image were brighter or a little bit darker. This electronic manipulation is not necessarily a good thing. If you have no light and you have no choice but to use this process, you can get an image. Now, the image might not look great because as you do this, as you manipulate the image, it introduces what we call video noise. So if you look at these images, you can see one of them is shot with no gain whatsoever. The other one is shot with a lot of gain. It's the same image, but you can see that in the one, there's snow or static. That's what we call video noise. The other one looks pretty decent. Every sensor has a native sensitivity. This is how sensitive it is if you do nothing, if you do not electronically enhance the signal. And ideally, if you're shooting, you want the sensor operating at that native sensitivity. You don't want to manipulate the signal if you don't have to. Now, sensitivity is measured in two very different ways. This is unfortunate, but it's the way life is. Decibels and ISO. Now, this is a historical divergence of technologies here. For cameras that have a background as being film cameras, right? This is a perfect example. This camera was designed to shoot film. Film used to be rated by how sensitive it was. And that scale was the ASA scale, American Standards Association, which later got changed to the ISO scale, the International Standards Organization. So the world adopted the American standard of measuring how sensitive to light film is. And it's a system that makes a lot of sense. You simply double the numbers to indicate a one-stop increase in sensitivity. That sounds pretty common, right? It sounds just like the shutter speed, actually. So if you had a set of film stock that was ISO 100 and some film stock that was ISO 200, the ISO 200 is one stop more sensitive to light than the ISO 100. Our cameras do not use film, but it's a really convenient way to measure sensitivity, and it's a really easy way to manipulate because, again, you just multiply by 2 or divide by 2. So the native ISO for our JVC cameras is ISO 800. That's a good number to keep in the back of your head somewhere. For cameras that came from a television background, or for cameras that were designed to be video cameras, there never has been film, right? There's never been part of film in video. There's never been part of film in broadcast television. It has always been an electronic signal from the camera to the viewer, right? It is it is electronically captured in the camera. It's electronically manipulated by the broadcaster. It's electronically sent through the airs. It's electronically received on a screen where it's displayed electronically. It doesn't exist anywhere. There's nothing tangible about it except for the fact that it's an electronic signal. So the most intelligent way to measure it, at least from an engineering standpoint, is by measuring the voltage of that electric signal. And one way to do that is to use the decibel scale. Decibels are normally used in audio, but they're a very convenient way to measure things logarithmically. I know, we're getting too deep into engineering. But this is why the idea of decibels as a measurement of sensitivity persists, because the cameras that we're using now are electronic. And this is the way that you manipulate the electronic signal, by increasing the voltage or decreasing the voltage. And the measurement for how much you've increased or decreased it is in decibels. So every 6 decibels of gain is one stop of brightness. Right? So if you go from 0 dB gain, means we have no gain, to 6 dB gain, you've made the image one stop brighter. If you go to 12 dB gain, you've made it 2 stops brighter, right? 6 plus 6 is 12. This system makes sense from an engineering perspective, but is a little bit more difficult to juggle in your head, remembering that 6 dB is one stop and We're going to contradict that when we get to audio. But for video purposes, 6 dB of gain is 1 stop of brightness. For the examples that we use in class and for the shooting purposes, I'm going to leave everything in ISO because I think it's a little bit easier to manipulate. But I don't want you to forget that gain exists because, again, when you get out there in the job world and you start working at a television studio or a video production house, it may well be that the cameras are measured in gain. In fact, probably the cameras will be measured in gain. Okay. We've added our third variable, right? So we have our aperture setting, we have our shutter speed setting, and now we have a gain setting, a sensitivity setting. So let's take a look at some possible examples. Now this is a very commonplace one. You're shooting inside a dark area. For example, you're shooting a play, and the lighting is very moody. So your iris is all the way open at f1.4. Your shutter speed is as slow as you can go. It's at 1/30th of a second. And the image is still too dark. You think it's about 2 stops too dark. How can you make it 2 stops brighter? You're going to have to add gain. So if the camera was at 800 ISO, which is its native setting, is probably where it was, you're going to have to make it 2 stops brighter. So we're going to double that twice, to 1600 and to 3200. So you change the ISO from 800 to 3200, and boom, Bob's your uncle, everything looks great. If you were doing that with gain, it would be a change from 0 dB gain to 12 dB gain, right? You go from 0 to 6 is 1 stop, and then from 6 to 12 is the second stop. This next one is fun. So starting at ISO 800, you're shooting at f5.6 at 1/60th of a second. I tell you to close the iris down to f16 and make it work. So what are you going to do? Closing from f5.6 to f16 means you've closed 3 stops. Your image is now 3 stops underexposed. You need to make that up. You need to find 3 stops of brightness somewhere else. One easy way to do this is simply to increase the gain by 3 stops. So we go from 800 to 1600 to 3200 to 6400. So simply increasing the gain to 6400 ISO would work. But it's not the only possible answer. So let's go back to ISO 800 for 3 stops underexposed. We need to get 3 stops back. But we're at 1/60th of a second. So we could actually get 1 stop by going from 1/60th down to 1/30th. Now we're only 2 stops underexposed, which means we can bump the ISO those 2 stops. So we go from 800 to 1600 to 3200. So there are 2 different solutions to this one, which is common. There are often more than one solution to the sorts of problems I'm going to be asking you. So if there's more than one right answer, is one better? Sometimes yes, sometimes no. In this particular case, remember that I told you, as you add gain, you add video noise. So the more gain you add, the more noise you add. I want to minimize the amount of noise that I'm adding to this picture, so the solution I'm going to choose is to slow the shutter speed by 1 stop, so I only have to use 2 stops of gain, rather than using 3 stops of gain.